init needs to call our designated initializer. If we then defined a id inits with age method, that should be int, then this must also call our designated initializer, and we'll use the defaults up above, John, and age. So there should always be one initializer, which is your designated initializer. And also, that designated initializer needs to call the designated initializer of your parent class. So notice that init and init with age are not calling super init. It's only our designated initializer which is calling super init. So that's just, if you start defining your own initializers, just make sure you follow this convention, and you can remember it just Googling designated initializer. And also notice that I should not do this. Why is it? I should not do this, because this is not appropriately setting self. So we want to set self to whatever that happens to return, and then return self. Questions? And then going back to main, now we see that all in one line, we're allocating a student, initializing it with the name Alice and the age 20.
Sorry, can you explain why we use super
In here?
Yeah.
So imagine we are, go back to the example from a while ago where we have like NS object, then we have person, then we have student, then we have 8th grader. So I want to define a new initialization method for 8th grader. And I decide that to initialize it, like say it has an instant 8th graders, let's say kindergartner. So kindergartner has an instance variable favorite color. And so we decide that like the default value for that instance variable should be blue. So we define an initializer that says this should be blue, except if we don't then call super init, super now refers to, if we are a kindergartner, super refers to student. And so if we don't call super init, then we're not initializing all these instance variables that happen to come from the student class and the person class and the NS object class. So you should always initialize your superclass, similar to like you should always initialize any object that you allocate. You should always initialize your superclass. And these two methods happen to initialize the superclass by calling the designated initializer, which initializes the superclass. But again, this pattern, like this is the pattern for writing your own initializer. So you should almost always copy and paste this, and then like in these curly braces is where you set your instance variables, or nslog, whatever it is you want to nslog.
So they would always just initialize the super.
Yeah. Because there might be something in that superclass that is like essential for everything else to work. Any other questions?
Why again is that the function why does it not need the super?
Why does init with age not need it? Because it's calling init with name and age. It's calling this method, which itself calls super init. Okay, we'll take the 5-minute break. Okay, so am I now louder? So now talk about collections for just a second. The only ones we're going to see right now are this NS array and NS mutable array, where NS array is an immutable array, which pretty much means like once it exists, it is what it is. You can't change it, especially Mutable array is going to be useful, that we're going to be able to just keep adding things to it. NS dictionary and NS mutable dictionary. So those are going to be useful for like key value pair type stuff. Associative arrays, maps, whatever, hash tables, whatever you want to call them, that's what you're going to use those for. Sets, just another example of a collection. NS array is going to be the most commonly used, and we're going to use it right here. So looking at the next example. Okay, so students.h and students.m haven't changed. It's main.m. Now we're trying to do something interesting where we have an NS mutable array of students, and we're just allocating it and initting it. And then we want to insert into that array Alice and Bob. So we've done it in one line. If we wanted, we could do the same thing. We could do boom. So the NS mutable array class defines an instance method called addObject that is just going to take some argument with type ID. And so since student star is an object type, that is an appropriate ID. And then we're going to do that again with Bob. So you can think of this as an array where the first element is Alice and the second element is Bob. And then here is, I referenced this a while ago, that we have this for in syntax that we're able to use with collections. So this will also work for dictionaries and sets. So for each student in this NS mutable array, we want to greet that student. So one thing that's somewhat important to remember is that everything inside of this array is just stored as an ID. Like, there's nothing enforcing that I only put students into this array. If I wanted, I could put a student and then a string and then another student and then some UI table view controller. It's up to you to enforce that everything is of the same type. Or if you don't want to enforce that, you need to just make sure it makes sense, you know what you're doing. But like, if I wanted, I could say this, and this isn't going to work because NSString doesn't have a name and age instance variable, but it doesn't know what's inside of the student's array. So for all the compiler knows, it is an NSString. This is where it can be somewhat dangerous dealing with ID. And this is also why you might need to be dealing with casts. So you might want to cast these return values to the appropriate things. Okay, so questions on this iterating over an array? Yeah?
How does it know like what order to iterate over?
So it's, how it's working underneath the hood is that this NS mutable array class needs to define how to iterate over it. And so in this method that it's defining for how to iterate over it, it's saying that, like, I'm going to do it in this order. So it's saying that, like, index 0 is the first thing that should be returned, then index 1, then index 2.
Is there any way to add generics to it?
So we'll see. I don't think there is to directly to arrays. We'll see, though, that protocols at the very least are ways to make IDs a little stronger. They're ways to make sure that these IDs are at least objects that conform to a specific interface. I don't think there's any generic type construct in the language. Okay. Okay, so that's the syntax we just saw. And notice here we are saying for ID foo in bar. And so we don't know what is inside a bar, and so all we can really say is ID unless you happen to know what it really is. Okay, so categories is actually, let's ignore that for a second. Let's do another example first. Students 8. Okay, so the point of this example is I've decided